Determine whether the following function has inverse, hence find the F inverse. So there are two parts. The first thing you have to determine by using algebraic approach, or we can use the horizontal line test. Okay, and secondly, after you determine it's a one-to-one function, then we're finding the inverse and also their domain and range will be the third part. Okay, so now we're looking at the question A and question B. So how we're going to solve it? Okay, for the question A, the function is a linear function which is 3x plus 2. So in order to showing this is a one-to-one function, the most easier way is using algebraic approach. Okay, or what we call it algebraic method. So the algebraic method, the main part is starting with f as 1 equals to f as 2. And we are able to prove that s1 is equals to s2. So the answer would be yes, it is one-to-one function. Okay, so we start from this. So from here, we get that 3x1 plus 2 equals to 3x2 plus 2. 3x1 equals to 3x2. And lastly, we are able to prove that s1 equals to s2. So we have to draw conclusion. Therefore, fx is one-to-one function. Thus, so the second summary is F inverse exists. So the first part have done. So now we need to go and find the F inverse by using opposite function method. F of F inverse equals to X. So 3F inverse plus 2 equals to X. So it will give you F inverse is equals to 1 over 3 X minus 2. So both you will get that it's linear function. Okay, because as we know the linear function, the domain is real number, so there is no problem to determine the domain. It will be real number, and the range also real number. Okay, it's by using the relation between the function and the inverse. Okay, so this is the third part, this is the second part, and this is the first part. So we have done with this question. Okay, so now proceed to question B. We can show there is a one-to-one function or not one-to-one function by two different methods. So firstly, we can try to using the algebraic approach, which is f as 1 equals to f as 2. So s1 squared plus 4s1 plus 1 equals to s2 squared plus 4s2 plus 1. So from here, we eliminate the constant 1. And we left all the terms in x1 or x2. Okay, we bring the square form into to the left hand side, and the right hand side is the negative 4s1 because we're moving positive 4s1 to the right hand side. And lastly, we do the factorization. So from here we get x1 minus s2, s1 plus s2 by using concept a squared minus b squared is equals to a minus b, a plus b. So we're using the algebraic. Okay, and the right hand side, we factorize out the negative 4. So we get s1 minus s2. So obviously from here, these two will be eliminated. And lastly, we get that s1 is equals to negative 4 minus s2, which is not given you the s1 equals to s2. So from here, we can draw conclusion, therefore, fx is not one-to-one function. So when it is not one-to-one function, automatically we will draw another conclusion. F inverse does not exist. So we no need to find the F inverse once you recognize it is not one-to-one function. Okay, so now for the question C, hx equals to square root function x minus 2, and the domain is given x greater or equals to 2. So we try to use graphical approach. So we can sketch the graph. So as we know that this one, we'll read this coordinate as a 2 plus 0 as a 0. So x equals to 2, y equals to 0. So the graph will be right side of the 2. So by using horizontal line test, y equals to k. So there are only one intersection point. So it means it is one-to-one function. So but we have to write down in sentence by using horizontal line test. The straight line, horizontal line, y equals to k, intersect function fx, sorry, in this case, the function hx. We write it properly, function hx at one point. Therefore, it is one-to-one function. Thus, h inverse as is. Okay, so this is the first part. And the second part, we need to find the f inverse. So by using, in this case, we have to using h of h inverse equals to x square root h inverse minus 2 equals to x. So h inverse minus 2 equals to x squared. H inverse equals to x squared plus 2. Okay, so we have done finding the inverse. And the last part, we have to determine the domain of h. So actually it's given by the question, which is 2 to infinity. Automatic is the range of the inverse, the range of the h. So we're reading the coordinate from here. The value is 2 for x, so y for 0. So it would be 0 to infinity. Automatic is the domain of